Hello friends, welcome to this video. In the previous session, you learned about algebraic expressions. In this video, we will learn about their factorization. Can you tell what will be the product of the numbers 3, 5, 7? Yes, their product will be 105. Here, you can see that the numbers 3, 5 and 7 are factors of 105 and thus we just did the factorization of 105. Therefore, we can say that writing the numbers as a product of its factors is called factorization. Here you will notice that the number 105 can also be written as the product of 21 and 5. So will 5 and 21 be also called factors of 105? Think about it. Yes, 5 and 21 are also factors of 105. But in the factorization method, it is essential to write the factors in irreducible form. So let's move ahead and understand the factorization of algebraic expressions. Let's look at this algebraic expression 3q. Can you tell what kind of algebraic expression this is? As you can see, there is only one term in this algebraic expression. Therefore, it is called a monomial. Can you now factorize this term? Yes, we can write the term 3q as the product of 3 and q. Similarly, we can factorize the algebraic expression 84xyz. We can write this expression as the product of factors 84, x, y and z. Here, 84 is a non-prime number whose further factorization is possible. Solving this further, we get 2 multiplied by 2 multiplied by 3 multiplied by 7 multiplied by x multiplied by y multiplied by z. Thus, we have done the factorization of 84xyz. So far, we learned to factorize monomials. Is it possible to factorize binomials? Consider this binomial 5x squared plus 6z. Here, we can write the first term 5x squared as the product of 5x and x, and the second term 6z can be written as the product of 2, 3 and z. Isn't it easy? So friends, in this session we learned to factorize monomials and binomials. In the next video, we will see some more examples related to factorization. Thank you. Hello friends, welcome to this video. In the previous video, we learned to factorize monomials and binomials. Today, we will see some more examples related to factorization. Factorize the algebraic expression 3x minus 6y. If you want, you can pause the video and think about your answer. This algebraic expression has two terms, 3x and minus 6y. Here, we can write 3x as the product of 3 and x and minus 6y as the product of minus 2, 3 and y. If you look carefully, you will notice that factor 3 is the common factor in both the terms. So we can write the factors of this expression in this way. So let's find the factors of the next algebraic expression. If you want, you can find the answer by pausing the video. This algebraic expression has three terms. Like the previous example, we can write this expression in the same manner. When we factorize the expression 3x minus 3y plus 9z, we get two factors, 3 and x minus y plus 3z. So now, can you factorize these algebraic expressions? These questions have been given to you for practice. Their answers are as follows. So friends, in this video, we saw some examples related to factorization. In the next video, we will do an interesting activity related to factorization. Thank you. Hello friends, welcome to this video. In the previous video, we saw some examples related to the factorization of monomials, binomials and trinomials. Today, in this video, we will do an interesting activity related to factorization. Let us now discuss this algebraic expression in detail. This algebraic expression has three terms. We can represent the first term of this algebraic expression by the first figure, whose area is x squared. We can represent the second term with these three rectangular shapes. The area of each of these shapes is x, and thus the combined area of the three shapes is 3x. We can represent the third term in the form of these two small squares whose total area is 2. In this way, when the area of all shapes is added, the total area of the new figure obtained will be x squared plus 3x plus 2. Can you arrange these shapes in a rectangle or a square? Since this figure cannot be arranged in a square, we will try to arrange it in a rectangular form. Can you tell what will be the dimensions of the rectangle thus formed? Yes, the dimensions of the rectangle formed are x plus 2 multiplied by x plus 1. This means the area of this rectangle will be x plus 2 multiplied by x plus 1. Therefore, we can say that the algebraic expression x squared plus 3x plus 2 can be written as x plus 2 multiplied by x plus 1. The product of x plus 2 and x plus 1 gives us the same algebraic expression. Hence, they are called factors of this algebraic expression. So wasn't this an interesting method to do factorization? In this video, we learned about a method to factorize algebraic expressions. Hope you have understood the meaning of factorization well. Thank you.
Hello friends, welcome to this video. In the previous video, we learned the meaning of factors of algebraic expressions. In this video, we will learn about the method of factorization and regrouping algebraic expressions. Do you remember that you had learned about common factors in the previous session? Can you find out the common factors of 24x and 48y? We can write factors of 24x and 48y in this manner. Here we can see that 24 is common in both the factors list, which we will call as common factor of these two terms. Among the factors of the terms of algebraic expressions, the factor which is common in all the terms is called the common factor. It is used to factorize algebraic expressions. Let's see this algebraic expression. Which are the terms you can see here? Can you find the factors of these terms? This algebraic expression has two terms. We can express both terms in the form of its factors. Now, can you find common factors here? We can see that 3xy is common in both the terms. So, the common factor of the terms 6x square y and 3xy square is 3xy. Now we can write this algebraic expression as a factor of its terms in this way. We can see that 3xy is the common factor. So now we can write 3xy times 2x plus y using the distribution law. 3xy times 2x plus y is the factor of the given algebraic expression. Wasn't that easy? But we see that it is not possible to find a common factor for all the terms of an algebraic expression. Look at this algebraic expression. 15mn plus 15 plus 9n plus 25m. Here we don't have a common factor for all the terms. We will use the regrouping method to factorize such polynomials. In this method, the algebraic expressions are rearranged and grouped. First of all, we will factorize all its terms. We did not find any common factor in these four terms. But we can see that 5m is common in the first term 15mn and fourth term 25m. And 3 is common in the third term 9n and in the second term 15. So we will rearrange these terms in this way and write them as factors. Now you can see that 3n plus 5 is common. So we write it in the same manner. Hence the factors of the algebraic expression 15mn plus 25m plus 9n plus 15 are 3n plus 5 and 5m plus 3. Thus we have learned to factorize by regrouping method. So in this session, we learned about the factorization of algebraic expressions using the common factor and the regrouping method. In the next video, we will see examples related to it. Thank you. Hello friends. In the previous video, we learned about the different methods of factorizing algebraic expressions, that is, the common factor method and the regrouping method. Today we will see some examples related to this. Look at these terms. Can you find their common factor? We can write the factors of 33xy like this. Similarly, we can write the factors of 11x square y cubed like this. And we can write the factors of the term 22y square z cubed like this. We can see that in these three terms, 11y is the only common factor. Now can you factorize the algebraic expression 4x square y plus 10xyz? You can pause the video here and think. Let's see. First of all, we will find the prime factors of all the terms of algebraic expressions in this way and write them as factors. We can see that 2xy is common in both terms. Therefore, we can solve the algebraic expression in this way. Hence, the expression 2xy and 2x plus 5z are factors of 4x square y plus 10xyz. Wasn't that easy? Let's look at another example. What will you do if you wanted to factorize this algebraic expression r minus 5pq plus pqr. You can pause the video here to think. You got it right. We will first write the factors of all the terms of this algebraic expression in this way. All these terms do not have any common factors, but between the third term minus 5pq and the fourth term pqr, there is a common factor pq. So we can write the given algebraic expression as follows. Here pq is the common factor in the last two terms. So we can solve it further in this way. We can see here that if we consider r minus 5 as a term, we can write it further in this way. Hence, the factorization of the given expression will be r minus 5 multiplied by 1 plus pq. We can rearrange this expression in another way. If we write the first and last terms together and write the second and third terms later, what are the common factors you see? Here r is common in the first and second term, and minus 5 is common in the third and fourth term. So we can write it this way as well. Here we wrote r plus pqr as r multiplied by 1 plus pq, because we can also write r as 1 multiplied by r. If we multiply both of these, then we get r plus pqr. Similarly, we can also write minus 5pq as minus 5 multiplied by 1 plus pq. We can see that here we are getting the same factors. Now practice these questions. You can pause the video here to think. So in this video, we learned factorization of algebraic expressions using the common factor method and regrouping method. Thank you.
Today we will learn factorization by using identities. While learning about algebraic expressions and identities, we have discussed some standard identities. Here, the left side of standard identities is shown. Will you be able to tell their right side? Try it. Let me tell you, do you know, with the help of these identities, we can also find the factors of some expressions. Suppose we want to find the factors of 4x square plus 20x plus 25. Are there any common factors in the three terms of this expression? Think. No, there are no common factors in these three terms. Just think, we can factorize this expression using one of these standard identities. Let me tell you, there are three terms in this expression. There are two terms on the right side of the third standard identity, so we cannot use it. There are three terms on the right side of each of the first and second identity. So, let's understand which identity we can use. We can write 4x square as 2x square and 25 as 5 square. In this way, we see that the first term and the third term in this expression are perfect squares. At the same time, we also see that the sign of the middle term is positive. Can you tell me which of these expressions correspond to the right side of the standard identity? Think. Absolutely right. This expression corresponds to the right side of the identity a plus b bracket square is equal to a square plus 2ab plus b square. Therefore, we can use this identity. If we assume a is equal to 2x and b is equal to 5, then a square plus 2ab plus b square is equal to 2x square plus 2 multiplied by 2x multiplied by 5 plus 5 square, that is 4x square plus 20x plus 25, which is similar to the given expression. But according to question, a square plus 2ab plus b square is equal to a plus b bracket square. So we can say 4x square plus 20x plus 25 is equal to 2x plus 5 whole square. Thus, with the help of standard identity, we have multiplied this expression, and these are its factors. In this way, to factorize an expression, first we find the identity which has its right side similar to the expression. Then, we find the factors of the desired expression from the corresponding expression on the left side of that standard identity. Now suppose we want to factorize 9y square minus 36y plus 36. Then how will we do this? Think. Absolutely right. Here factor 9 is common in all three terms. So under the distributive property, we can take it outside the bracket like this. We can write the expression written inside the parenthesis like this. In this way, we see that the expression inside this bracket corresponds to the right side of the standard identity, where a is equal to y, b is equal to 2, and 2ab is equal to 2 multiplied by y multiplied by 2, that is 4y. Therefore, we can factorize this expression as y minus 2 whole square. Thus, this gives us the factorization of given expression like this. We can also write it like this. Now, pause the video and find the factors of 49x square minus 100. Let me tell you, we can write 49x square as 7x square and 100 as 10 square. In this way, both terms of this expression are perfect squares. It corresponds to the right side of this identity. A plus b, a minus b is equal to a square minus b square, where a is equal to 7x and b is equal to 10. Therefore, using the third identity, we can factorize the given expression as 7x plus 10 into bracket 7x minus 10. Now, find the factors of the expressions given below. So today we have learned factorization using identities. In the next video, we will see some interesting examples related to them. Today we will see examples of factorization using identities. Factorize the algebraic expression in 3x raised to the power 4 minus 3y raised to the power 4. We see that number 3 is the common factor. From the distributive property of multiplication over subtraction, we can take 3 out of the brackets is equal to 3 into bracket x raised to the power 4 minus y raised to the power 4. Can further factorization be done? Think. Let me tell you, we can write x raised to the power 4 as x square bracket square and y raised to the power 4 as y square bracket square. With this, we can write the expression this way. Now tell me, which identity can we use for factorization of given expression? Pause the video and try it. Let me tell you, we see that the expression written inside the bracket corresponds to the right side, that is, RHS of the third standard identity. Now, we can write it in this way using this standard identity. Again, here we see that the expression x square minus y square corresponds to a square minus b square of the third identity. That's why we can express this expression like this. We cannot factorize the given expression further. That is, we found all the factors of the given expression. Next example. The area of a square is in the form of expression 81k square minus 90k plus 25. What will be the length of a side of that square? We know that the area of square is the square of length of the side. We can write it as length of the side multiplied by length of the side. Looking at this, we can say that the length of side of the square is a factor of the area of that square. To find the length of the side of a square, we have to factorize the given expression. So, let's start. First, we will see if there are any common factors in all the terms of the expression. There are no common factors in all the terms. Now, let's factorize all the terms. The first term is the perfect square. We can write it as 9k square. The third term is also a perfect square, which we can write 5 square. The second term can be written as minus 2 multiplied by 9k multiplied by 5. Observe that the second term is negative. We see that this expression corresponds to the right side of the identity a minus b square is equal to a square minus 2ab plus b square, where a is equal to 9k, b is equal to 5 and 2ab is equal to 2 multiplied by 9k multiplied by 5, that is 90k. Therefore, we can factorize this expression as 9k minus 5 whole square. That is, the length of the side of the square is 9k minus 5. Next example. Factorize the given algebraic expression 80x raised to the power 4 plus 40x cube y plus 5x square y square. Pause the video and try to find the factors of this expression. Let me tell you, first we will check if there are any common factors in all three terms of the expression. Here, 5x square is a common factor in all terms. So, we take 5x square outside of the bracket, so we get this expression. Now, we can write the terms present inside the bracket like this. The arrangement inside the bracket corresponds to the right side of a plus b whole square is equal to a square plus 2ab plus b square. So, by taking a is equal to 4x and b is equal to y, we can write the terms inside the bracket as 4x plus y whole square. In this way, the factorization of given expression is 5x square into bracket 4x plus y whole square. Now, with the help of identities, try to factorize 121k square minus 64 by yourself. Today we have seen examples of factorization using identities. In the next video, we will see some mistakes related to them. Today we will see common mistakes related to factorization using identities. Mistake 1. Mistake related to arrangement of terms in algebraic expression. If children are asked to factorize this expression by using identities, then some children get confused after seeing that the terms are not in their standard form and so they could not factorize the expression. We need to arrange the terms in the expression in order to do the factorization. X square and 49 are perfect squares in the given expression. So, we can arrange this expression in this way. Now, we can factorize this with the help of this identity. Thus, we get the result as x minus 7 whole square. Now, will you be able to factorize minus x square plus 25? Try it by yourself. Mistake 2. Mistake in the selection of identities. If some children are asked to factorize algebraic expressions x square minus 6x plus 9, they answer x plus 3 whole square in hurry. But it is a wrong answer. This happens because here children see that 9 is a perfect square and the variable x is also a square. So, they think that identity 1 is used to factorize the algebraic expression shown. They does not notice here that there is a minus sign between x square and 6x. Since the algebraic expression shown has a minus sign between x square and 6x, therefore, identity 2 will be used here. Therefore, the desired factorization of algebraic expression x square minus 6x plus 9 is x minus 3 whole square. Mistake 3. Not using identities a square minus b square is equal to a plus b, a minus b correctly. Some children are unable to use the identity a square minus b square is equal to a plus b, a minus b correctly. They factorize the algebraic expression 9x square minus 36 like this, which is the wrong factorization. Keep in mind that the first term here is 9x square, which is the square of the term 3x. Similarly, the number 36 is the square of 6. In this way, there are a is equal to 3x and b is equal to 6. So, the correct factorization will be 3x plus 6 into bracket 3x minus 6. So, today we have seen common mistakes related to factorization by using identities. Today we will learn about factors of the form x plus a into bracket x plus b. Suppose we are required to factorize this algebraic expression. Can we use these identities? Think. Let me tell you. Here, the number 20 is not a perfect square. So, this expression is not of type a plus b bracket square or a minus b bracket square. That is, it is not a square expression. Similarly, we also see that it is also not an expression of type a square minus b square. Here, we will use this identity. If the expression corresponds to the right side of this identity, then its factors correspond to the left side of the identity. This is the fourth identity of algebraic expressions that we have studied earlier. Let's try to arrange this expression. According to this identity, if we compare this expression with the right side of the identity, then we see that the coefficient of x square is 1, just like the right side of the identity. In the same way, the coefficients of the second term in both expressions gives a plus b is equal to 9 and coefficients of the third term, that is constant term in both expressions, gives ab is equal to 20. Now we will find the values of a and b so that both these conditions are satisfied. That is, we need two numbers whose product is 20 and sum is 9. Will you be able to find two such numbers? Think. Let me tell you, two such numbers are 4 and 5 because 4 multiplied by 5 is equal to 20 and 4 plus 5 is equal to 9. In this way, we can write the middle term 9x of the expression x square plus 9x plus 20 as 4 plus 5x. In this way, we have arranged the given expression as the right side of this identity. We can write it like this by removing the brackets. X square plus into bracket 4 plus 5 x plus 20. X square plus 4x plus 5x plus 20. The first two terms have x as their common factor. So we can take x outside the brackets and represent this group as x into bracket x plus 4. Similarly, 5 is the common factor between the third and fourth terms. So we can also take it outside the bracket and write this group as 5 into bracket x plus 4. Now we see that x plus 4 is a common factor, so we can take it common and write the expression as x plus 4 into bracket x plus 5. In this way, the factorization of x square plus 9x plus 20 is x plus 4 into bracket x plus 5. Generally, to factorize the expression of type x square plus bx plus q, we find two factors a and b of constant term q such that ab is equal to q and a plus b is equal to p, using which the expression can be arranged as x square plus a plus bx plus ab. It can be written as x square plus ax plus bx plus ab. With further factorization like this, we will get x into bracket x plus a plus b into bracket x plus a, which is equal to x plus a into bracket x plus b. These are the factors of x square plus bx plus q. In this process, we have splitted the middle term. Thus, we also understand this process by the name middle term splitting. So, can you tell me how we can factorize x square minus x minus 42? Pause the video and try it. Let me tell you, here the coefficient of x square is 1, the coefficient of x is minus 1, and the constant is minus 42. We have to find two numbers a and b for which product is minus 42 and the sum is minus 1. The conditions in which we get the product of two numbers minus 42 are as follows. Now, can you find the two factors of 42 which when added gives result minus 1? Think. Correct. The sum of 6 and minus 7 is minus 1 and so we will choose 6 and minus 7. Now we can write 6 minus 7 at the place of the coefficient of x, that is minus 1, in x square minus x minus 42. Thus we get the expression x square plus 6x minus 7x minus 42, that is x into bracket x plus 6 minus 7 into bracket x plus 6, that is x plus 6 into bracket x minus 7. Solving in this way, we will get the factorization of the expression x square minus x minus 42 as x plus 6 into bracket x minus 7. Now, you must have understood this method very well. So today we have learned the factors of the form x plus a into bracket x plus b. In the next video, we will see some interesting examples related to them. Today we will see some examples related to factors of the form x plus a into bracket x plus b. Area of rectangle has algebraic expression. Find the expression for the length and the breadth of this rectangle. We know that the area of a rectangle is length multiplied by breadth. Here, the area of rectangle is given in the form of algebraic expression x square minus 12x plus 32. If we factorize it, we will get an expression for length and breadth of rectangle. So, let's get started. Here, we will use this identity. We will divide the middle term, that is, the coefficient of x, into two numbers a and b in such a way that ab is equal to 32 and a plus b is equal to minus 12. Since minus 8 multiplied by minus 4 is equal to 32 and minus 8 plus minus 4 is equal to minus 12, we will choose minus 8 and minus 4. Now, the middle term minus 12x of this expression can be written as, which can also be written like this. Now, we will take x common from these two terms and minus 4 common from these two terms. Now, we will take x minus 8 in common from both these terms so that we get the factorization of given expression as x minus 8 into bracket x minus 4. We know that the area of a rectangle is equal to length multiplied by breadth. Therefore, we can say that the length of rectangle is x minus 8 and breadth is x minus 4, or the length of rectangle is x minus 4 and breadth is x minus 8. Now, let us understand an interesting thing related to factorization of algebraic expression with an example. A teacher asked students to factorize the given expression. Tina and Sachin solved it with two different methods. Tina simplified it by splitting the middle term, that is, she used this identity. She had found two numbers a and b to split the middle term minus 12x in such a way that ab is equal to 36 and a plus b is equal to minus 12. Since minus 6 multiplied by minus 6 is equal to 36 and minus 6 plus minus 6 is equal to minus 12, so she chose minus 6 and minus 6. She expressed the middle term minus 12x of this expression as, she simplified it in this way. She took x from these two terms, minus 6 from these two terms as a common factor. Then, from these two terms, she took x minus 6 as the common factor. Thus, she obtained the factorization of the given expression as x minus 6 into bracket x minus 6, which we can also express as x minus 6 bracket square. Instead of solving like Tina, Sachin used identity to factorize the given expression. In this expression, the first term x square and the third term 36 are both perfect squares. Sachin wrote the second term minus 12x as minus 2 multiplied by x multiplied by 6 and wrote the given expression like this. The expression corresponds to right side of this identity where a is equal to x, b is equal to 6 and minus 2ab is equal to minus 2 multiplied by x multiplied by 6, that is minus 12x. Therefore, we can write the factorization of this expression as x minus 6 bracket square, similar to the left side of the identity. Thus, both have obtained correct answer. In this way, we have seen that the factorization of given expression can be done by using standard identity as well as by dividing the middle term, that is, using this standard identity. Generally, the expressions that corresponds to right side of these identities can also be factorized by the middle term splitting. So today we have seen some examples related to factors of the form x plus a into bracket x plus b. In the next video, we will see some simple mistakes related to them. Today we will see some common mistakes related to factors of the form x plus a into bracket x plus b. Mistake 1. Children are not able to split the middle term correctly while factorizing an algebraic expression of type x square plus into bracket a plus b x plus ab. For example, if they are asked to factorize the expression x square plus 8x plus 12, then they split the middle term 8x as 4 plus 4x. They do not understand that the numbers taken should be factors of constant term 12. After dividing the middle term, they simplify it in this way. Some children are unable to simplify this further and think that the factors of given expression cannot be found. Some children think that x plus 4 can be taken as common here, so they write this expression as x plus 4 into bracket x plus 3. These are wrong answers. We can only take a factor common if it is a factor of at least 2 terms. Keep in mind that to do the correct factors, we have to choose those factors of 12 whose sum is 8. Such factors are 6 and 2. So we can write x square plus 8x plus 12 as x square plus into bracket 6 plus 2 x plus 12, which on further solving we get. Here you can see that x plus 6 is the factor of both these numbers, so x plus 6 is a common factor. Hence, we can take x plus 6 common. In this way, we will get x plus 6 and x plus 2 as the correct factors of this expression. Mistake 2. The number written before the variable is called its coefficient, just as in 2x has coefficient of x is 2. In 9x square, coefficient of x square is 9. If the coefficient of a term in the expression is 1, we generally do not represent it. For example, the coefficient of both x square and x is x square plus x minus 2 is 1. Some children do not have this idea, so they are not able to factorize algebraic expressions like x square plus x minus 2. Remember, if no coefficient is given in any term, then in that case we should take coefficient 1. So here we will take coefficient of middle term x as plus 1. In this way we can write minus 2 is equal to 2 multiplied by minus 1, from which we will get 2 plus minus 1 is equal to 1. Now we can write x square plus 2x minus x minus 2, so that we get the factors of this expression as x plus 2 into bracket x minus 1. Mistake 3. Some children do not understand that the coefficient of x square is 1 in the identity x square plus into bracket a plus b x plus ab. So we can use this identity only if the coefficient of x square is 1. If children are asked to factorize algebraic expressions 3x square plus 3x minus 18, then they do not pay attention on the coefficient of x square, that is 3. They keep it simple, but at times they reach a situation when they cannot simplify further, so they think that given expression cannot be factorized. Note that if the coefficient of x square is any other number than 1, rearrange the expression and bring it in the form of x square plus into bracket a plus b x plus ab. For example, here if we take 3 common to all terms, then we get 3 into bracket x square plus x minus 6. Now we can factorize x square plus x minus 6. For this, we will find two numbers whose product is minus 6 and sum is 1. Those numbers are minus 2 and 3. That is, the factorization of given expression is 3 into bracket x minus 2 into bracket x plus 3. So today we have seen common mistakes related to factors of the form x plus a into bracket x plus b, x plus b, x plus b, x plus b. Today we will learn the division of algebraic expressions, in which we will learn division of monomial by another monomial. If an algebraic expression has one or more terms which have non-zero coefficients and non-negative integers as powers of variables, then such expression is called a polynomial. For example, these are all polynomials. If there is only one term in an expression, then we call it monomial. An expression with two terms is called binomial. An expression with 3 terms is called trinomial, and so on. In many cases, we have to divide one monomial with another monomial. To understand how they are divided, let's see an interesting example. We have to find the result of 15x cubed divided by 10x square. We can write it like this. Now, we will write both numerator and denominator in the form of their factors. Here we can write 15x cubed as 3 multiplied by 5 multiplied by x multiplied by x multiplied by x, and 10x square as 2 multiplied by 5 multiplied by x multiplied by x. Here 5 multiplied by x are common to numerator and the denominator. So, we will cancel them in the numerator as well as denominator. We call this method as cancellation. This gives us result 15x cubed divided by 10x square as 3x divided by 2. Let's take another interesting example. Pause the video and try to divide 21x cubed y square z by 7x cubed z. What is the result? Let me tell you. We can write the factors of 21x cubed y square z like this and the factors of 7x cubed z like this. By cancelling the common factors in the numerator and the denominator, we get the result of division as 3y square. Now, you will be able to divide one monomial from another monomial. So today we have learned the division of algebraic expression, in which we learned division of monomial by another monomial. In the next video, we will learn division of polynomial by a monomial. Today we will learn the division of algebraic expressions, in which we learn division of polynomial by a monomial. Suppose we want to divide this polynomial by a monomial 4x square. For this, we will first represent it in the form of numerator and denominator. Now, we will factorize each term of the numerator. Here, the factorization of 20x square y square can be done like this. 12x square y and x cube can be done like this. Similarly, we will also write factors of denominator. Here, 4x square can be written like this. Now, we have to take a number common from each term of the numerator. The number must be equal to the denominator, so that we can cancel it with the denominator by the method of cancellation. In this way, we will take 2 multiplied by 2 multiplied by x multiplied by x common from each term in the numerator. This will leave 5 multiplied by y in the first term and 3y in the second term. Can you tell me how we can take 2 multiplied by 2 multiplied by x common from the third term? Think. Let me tell you. We can write the third term like this by arranging it, where the value of 2 multiplied by 2 multiplied by 1 divided by 2 multiplied by 2 is 4 multiplied by 1 divided by 4, that is 1. In this way, there is no change in the value of this expression. Now, we can take 2 multiplied by 2 multiplied by x common from the third term as well. After taking this number common, 1 by 4x will be left in the third term. Now, we can cancel the common factors 2 multiplied by 2 multiplied by x in the numerator and denominator. From this, we will get the result of division as 5y square plus 3y plus 1 by 4x. Let's solve this with another interesting method. We can divide each term of polynomial with a denominator separately. To find the result of the division from this, we can get the quotient of each term separately by the cancellation method. Here, we will write it like this. In 20x square y square divided by 4x square, when 20 is divided by 4, the result is 5. Similarly, you can cancel x square in both numerator and denominator. In this way, we will get 5y square from the first term. Now, can you tell me what is the result of division from second and third terms? Think. You are right. In the division of second term, 12 divided by 4 gives result 3, and we can cancel x square from the numerator and denominator. Hence, the result of division of second term will be 3y. Similarly, the result of the third term will be 1 by 4x. In this way, we will get the result 5y square plus 3y plus 1 by 4x. Now, find the result of given division yourself. m raised to 4 plus 4am square minus 16m cube divided by 2m. Now, you will be able to divide any polynomial with a monomial. So today we have learned the division of algebraic expressions, in which we learned division of polynomial by a monomial. In the next video, we will learn division of polynomial by another polynomial. Today we will learn the division of algebraic expressions, in which we will learn division of polynomial by another polynomial. Till now, we have learned division of monomial by another monomial and similarly division of polynomial by a monomial. Let us now understand how to divide a polynomial by another polynomial. Suppose we have to find the result of this. Think about how we can find the result. Let me tell you, first of all, we will write dividend and divisor in the form of numerator and denominator. Then we will write both the numerator and denominator in the form of their factors. Since 3x is common to all terms in the numerator, so we can write it like this. Now, can you tell me what is the factorization of polynomial x square plus x minus 12? Think. Let me tell you, we will split the middle term. That is, we will use this identity. Here, by dividing the middle term, 1x, in this way, we can find the factors of this expression as x minus 3 into bracket x plus 4. Now, we can write it as. Similarly, we can write the denominator in the form of factors as 3 into bracket x plus 4. We will see that the factors 3 and x plus 4 are common to both the numerator and the denominator, so we can cancel them. From this, we get the result as x into bracket x minus 3, that is x square minus 3x. Now, try to find the result of 7a raised to the power 4 plus 21a raised to the power 3 minus 70a square divided by 7a minus 35 by yourself. So today we learned the division of algebraic expression, in which we learned the division of polynomial by another polynomial. In the next video, we will see some interesting examples related to division of algebraic expressions. Today we will see some interesting examples related to division of algebraic expression. The relationship between speed, time and distance traveled by a vehicle is given as distance is equal to speed multiplied by time. If the distance traveled by a vehicle is obtained by an algebraic expression x cube minus 64x and its speed as x minus 8, what will be the expression for time? The relation between speed, time and distance traveled is distance traveled is equal to speed multiplied by time. If we want to find the time, then it will be time is equal to distance covered divided by speed. Since the distance traveled is x cube minus 64x and speed is x minus 8, time will be equal to x cube minus 64x divided by x minus 8. To simplify it, we have to divide numerator by denominator. Since there are more than one term in both numerator and denominator, so here we have to carry out division of polynomial by another polynomial. For this, we will write both numerator and denominator in the form of their factors. Now, by taking x common from the terms of numerator, we get x into bracket x square minus 64. We can see that 64 is the square of the number 8. Therefore, we can use this identity. Thus, numerator can be expressed in the form of its factors as x into bracket x plus 8 into bracket x minus 8. Now, we see that x minus 8 is common to both the numerator and the denominator. So, with the cancellation method, we can cut it in the both the numerator and denominator. This gives us the expression for time as x into bracket x plus 8, that is x square plus 8x. Let's see the next example. The volume of a cuboid-shaped tank is represented by this algebraic expression. If the height of this cuboid is 6m square n, find the area of the base of the tank. We know that volume of cuboid is equal to length multiplied by width multiplied by height. Here, by product of length and width, we will find the area of base of the cuboid. Therefore, we can say that the volume of the cuboid is equal to the area of the base of the cuboid multiplied by height. In this way, the area of the base of the cuboid will be equal to the volume of the cuboid divided by height of the cuboid, which we can write in this way. Here, we have to divide a trinomial by a monomial. Can you tell me how to do it? Think. Absolutely right. We can divide each term of the trinomial by monomial. Then, by the method of cancellation, we can find the quotient of each term separately. In this way, we get the area of the base of the cuboid as 3m square n square plus mn minus 2n. So today we have seen some interesting examples related to division of algebraic expressions. In the next video, we will see some common mistakes related to them. Today we will see some common mistakes related to division of algebraic expression. Mistake 1. Leaving the division of algebraic expressions incomplete. Some children leave the division of algebraic expressions incomplete. For example, if children are given the question and asked to simplify it, some children cancel y from the numerator and denominator by the method of cancellation. But after this, they think that numerator cannot be divided by denominator. So, they do not simplify the question further and leave it incomplete. To avoid this mistake, we can factorize the numerator and denominator while dividing the algebraic expressions. This allows the common factors to be cancelled by the method of cancellation and thus correct result can be obtained. Mistake 2. Students do not reduce the exponents of the variables when dividing algebraic expressions. If children are asked to simplify 6p cube divided by 2p, some children ignore the exponents of the variables and write the variable in the numerator and its power as such. This gives them the wrong answer 3p cube. If the variables are same, the power of the variable changes during division. The factors of 6p cube is 2 multiplied by 3 multiplied by p multiplied by p multiplied by p. Similarly, the factors of 2p will be 2 multiplied by p. Here, we will cancel 2 in the numerator with 2 in the denominator and p in the denominator with p in the numerator. It gives the result 3p square. The same can be solved with the help of exponent rules. Since a raised to m divided by a raised to n is equal to a raised to m minus n, hence 6p cube divided by 2p can be simplified like this, which gives the correct result as 3p square. Mistake 3. Incorrect use of cancellation method. Amir asked Samir to find the result of x square minus x square y square divided by x square. Samir solved it like this. Can you tell me if he got the right answer? Think. Let me tell you, some children like Samir think that if the polynomial is divided by monomial, the like terms in the numerator and denominator can be cancelled. With this understanding, they cut off one of the terms of polynomial by monomial. Here, Samir cancelled the denominator x square with the x square of the term from the numerator, but it is wrong. We have to divide each term of numerator by x square. We can do this by dividing each term of polynomial separately by a monomial, which gives us the correct answer 1 minus y square. Mistake 4. Not using brackets. Sometimes children use this sign to indicate division. For example, if they are asked to divide x square plus 4x by x plus 4, they write it in this way: x square plus 4x by x plus 4. Can you tell me what is wrong here? Think. Absolutely correct. Brackets are not used here. This causes the viewer to think that only 4x is being divided by x. Sometimes this causes confusion even when simplifying the example, and this increases the chances of making a mistake. Such a mistake can be overcome with the use of brackets and correct result can be obtained. So today we have seen some common mistakes related to division of algebraic expressions.